Did you know that AI models are being trained by video games? Since the 1940s, ever-evolving computer programs have led to video games increasing in scale and complexity. Now, in a somewhat full-circle moment, video games are being used as a foundation to test the sophistication of AI software designed for separate purposes. One of the earliest uses of video games for AI development was produced for the computer game Nim, a simple game in which two players take turns in removing, or nimming, objects from distinct heaps or piles. The AI opponent created for Nim in 1942 was able to regularly beat even the most skilled players. This use of an artificial opponent was later used for other games such as chess and checkers. But when arcade games were first developed in the 1960s, these games were initially produced with the intention to be played by two real-life players. It wasn't until the 1970s that single-player modes were introduced and popularized by games like Space Invaders in 1978. Space Invaders not only had varying difficulty levels, but also featured distinct movement patterns and in-game dependent functions based on the real player's input. Other games, such as Galyonkin and Pac Man, followed this up with increasingly complex algorithms to interpret and maneuver around the inputs from the real-life player. They also started adding human-like elements to the in-game characters, such as giving them distinct personalities. As time went on, AI tools such as finite state machines and real-time strategies started to be implemented into games. This meant that softwares were taxed with such things as incomplete information, real-time decision-making, pathfinding issues, and economic planning. When this started out, it was a little patchy, with AI not being able to compute what the real-life players were doing, and therefore cheating to achieve impossible outcomes, but these issues were amended in subsequent games. Entities such as non-playable characters, better known as NPCs, have also vastly increased in their realism when reacting to the mechanics of a game, and they provide more immersion in games now. Video game AI opponents have essentially been built around human input to evolve their mechanics and become increasingly strategic and complex, and so now can pose a huge challenge even to the most experienced real-life players. These days, we've gotten to a point where an AI software whose intended use is for an application other than video games can be trained to play sophisticated games and go up against real-life players. Use of this method has proven to speed up the training of different AI software. While some AIs initially showed success in defeating players in games such as Mario, they struggled with more complex games. Eventually, Google DeepMind produced the AI software AlphaStar and put it up against a professional player of StarCraft 2, a game based on complex strategic maneuvers. AlphaStar was the first AI system to beat a player of this skill level playing a game of this complexity. AlphaStar's behavior stems from what Google DeepMind called a deep neural network, an AI model which mimics human brains using layers of nodes to analyze data and learn patterns. When playing the game, AlphaStar receives inputs from the raw game interface and outputs instructions which result in an action within the game. Experts think this model may be useful to overcome other AI challenges, including machine learning research, translation and language AI models, as well as visual representation models based on imperfect information from a real individual.